Hello everyone, I'm HighSchoolPhysicist. Welcome back to my channel. My motivation in creating this channel is to talk about some topics in physics for audience at high school level or above. Today I'm going to be talking a topic entitled Significance of Some Physical Concepts. This video may attract some controversies, but all the conclusions are based on my personal judgment. Others may have their own judgments or opinions, so relax and enjoy. Before starting, let me mention the maths needed to follow my story in this video. That is logarithm. The agenda for today are: the first is my definition of significant or not, and then energy, mole, chemical potential, temperature, electric potential, entropy, and conclusion. This is my definition that I use to judge the concepts in my video. For significant, I mean it is important, indispensable, necessary, or sometimes irreplaceable. And for the non-significant, it's a kind of just use unit conversions or used merely for just convenience. I'll give you an example for a non-significant concept. An example is a dozen or 12 pieces. Buying eggs are convenient to use dozen, however, this is definitely not significant. Energy, mass, force, momentum, angular momentum, distance, velocity, acceleration, electric charge, pressure, etc. concepts in physics. Without doubt, these concepts are indispensable, necessary, and thus significant. Mole concepts in chemistry. 1 mole is defined as 6.02 times 10 to the power 23 amount of chemical substance. As 1 mole is merely a unit conversion, it is not significant. Next is chemical potential concept in chemistry. Chemical potential is defined as energy divided by particle, or the unit will be joule per particle. This is not merely a unit conversion, so chemical potential is significant. Temperature concept in thermodynamics. The unit of temperature is Kelvin, and 1 Kelvin equals to 1.38 times 10 to the power 23 joule. This number is a well-known Boltzmann constant. So as this is just only a unit conversion, so temperature is not significant. Electric potential concepts in physics. Electric potential is defined as energy divided by the number of electric charge, or in unit joule per coulomb, or in another unit it is called volt. I think electric potential is a significant concept. The last concept is entropy concept. Frankly, entropy is the most difficult one for me to judge, but this is really fun for me, and then read on. In thermodynamics, entropy is defined as energy as heat divided by temperature, or in unit joule per Kelvin. However, Kelvin is another kind of energy, so entropy is a kind of a ratio which is joule divided by another joule. But in statistical physics, entropy is defined as a natural logarithm of all possible configurations of a system, or omega. Entropy is symbolized as S equals to Kb natural logarithm of omega. Kb is the Boltzmann constant, which is 1.38 times 10 to the power of 23 joule per Kelvin. About all possible configuration of a system, I'll discuss in the next slide. Here I present the example of calculation of entropy. I start with three state with two particles situation, and we have three kinds of statistics, which is the first is Maxwell-Boltzmann statistic or MP statistics. The second is Bose-Einstein statistics, and the third is Fermi-Dirac statistics. For the MP statistic, the particles are distinguishable, and for the PE statistic, the particles are indistinguishable, and for the FD statistic, the particles are indistinguishable, and also there is another criteria, which is the maximum of one particle per state. So all the configurations are shown in the three table in the middle. All the possible configuration or omega for MP statistic, there are 9 possibilities, and for PE there are 6, and for the FD there are 3. Hence, the last row measure the entropy of each configuration. The first is Kp ln 9, Kp ln 6, and Kp ln 3. Last notes, energy or heat is a multiplication of entropy and temperature, while total energy is the sum of work and heat. Here we see that entropy has a limit the maximum work that can be done by a system given a finite total energy. In equilibrium, there is competition between energy and entropy of the system. Energy should be minimum, but entropy should be maximum. Then I conclude entropy is significant. In conclusion, I have presented some concepts and their significance, and they are summarized as follows. The concept of energy, etc. is significant, mole is not significant, chemical potential is significant, temperature is not significant, analytic potential and entropy both are significant. In this occasion, I want to thank my fellow calligraph. Consider subscribing to his channel. See you next time, and thanks for watching.